Okay, what's up guys? This presentation is going to be on abusing WCF endpoints for RCE and privilege escalation. My name is Chris Anastasio. I'm a pen tester for the last 3 years at a small consulting company called Enumeration. I do bug bounties sometimes. I'm a co-founder of a monthly hacker group in Palo Alto called Dark Corner. I have a couple certifications, and hacking is my life. So, agenda for this talk: brief intro into WCF, target enumeration. We'll look at an example vulnerable service, and then we'll look at a actual commercial antivirus that got exploited in a similar way to the example. The motivation for this talk: my friend got a number of CVEs in 2018 on an antivirus, a commercial network monitoring tool, and a bunch of VPN clients through this vector. I hadn't, and then he gave a talk about it also in 2018 at Echo Party, and I hadn't really seen anybody talk about WCF in the way that he had presented it before. And pretty much as soon as his slides dropped, I started looking for similar bugs and found one right away. I think this attack surface is underexplored and not super well known. Not that it hasn't been talked about before, but hopefully you guys will be motivated to go find some of these bugs yourself after the talk. So what is WCF? It's a framework created by Microsoft for creating service-oriented applications. It helps to simplify inter-process communications. The communications can take place over a variety of transport protocols, including TCP, HTTP, name pipes, and a bunch of others. So WCF endpoints are defined with an address, binding, and contract. And we'll look at the example vulnerable service to get a better idea of how to set that up. So this is the address. It looks pretty much like any other URL you would look at, except for that the scheme, the beginning part, is going to be synced up with whatever binding you choose, which is the transport protocol. So in the example service, we're using net TCP binding. So it's just like a raw TCP socket, but that again could be HTTP or net.pipe or a bunch of other things. And then after that, you have your host port and the path. So once again, bindings define the transport protocol, and the examples using net TCP binding. Finally, the contract is a way to define what functionality the service is going to have. And so the service contract attribute is applied to interfaces or classes to expose them as a service, and then the actual functionality gets decorated with the operation contract attribute, and that's going to be what the service is actually able to do. So target enumeration, hopefully you guys can see this. You can use WMIC to get a list of all running services on a local system that are running as system. So targets for privilege escalation. This is pretty good, but it lists all services running as system. If you're looking for these kind of bugs, you'll want to focus only on .NET programs because they're the ones that are most likely to be using WCF. So my buddy also wrote a pretty simple Python script that runs the same WMIC query, but then uses the PE file Python module to check the import table for mscore.e.dll, which I think I said on the next slide. And if you see that in the import table, then it's a pretty good chance that you're dealing with the .NET binary. So when I reran that command on my system, you can see the list got a lot shorter. I have highlighted the actual service that is going to get exploited later. There was a bunch of others also started by the antivirus that I didn't find any exploitable bugs in. So the vulnerable service, again, we have the service contract, operation contract, and then that actual definition for the loan function that is defined. And it just takes a string argument and runs a command. And then this stuff is mostly, this is mostly boilerplate for building a service, a Windows service in C#. Sorry. One point of interest is the binding security mode. So just for the example, I set the security mode to none. By default, the security mode for a net TCP binding is Windows. So you can't just talk to it, totally unauthenticated in the default configuration, but I just turned it off for this example. So now the next thing to do after looking at the service is to build a client to talk to that service. And so WCF clients and services communicate over channels to move messages through the WCF channel stack. To create the client for this service, I couldn't fit it in the screenshot, but above the main function, I have the same interface definition from the service. So I have the iVuln service interface, and I just copy pasted that from there. And then I use the channel factory to pretty much build the channel. And then after that, you can invoke whatever methods are defined in the service in the operation contract on that object. So, so I have a demo for this example service, so you can see. See if I can get my pointer over there. So I'm just showing that the service has been started. It's called Vuln WCF service, and you'll see calc get popped in the video. So this is just an example of how this could be RCE. It really just all depends on what binding the service is using and what kind of functionality is exposed. And although this seems super contrived, it's actually very similar to the vulnerability that my friend found in, I can't say the software, but a pretty popular network monitoring tool. It had a function exposed called start external process. And although there was authentication required, you could, it was hard-coded into the service, so you could figure out how to actually authenticate and do it. So it's actually not super unrealistic. So yeah, the bug that I found was a privilege escalation in Checkpoint's ZoneAlarm antivirus. I know a lot of people laugh and like, ZoneAlarm, I haven't heard of that in years, and I hadn't either. And pretty much I wanted to find a bug, and I know antiviruses usually run as administrator, so I just Googled best antivirus, and and this was in the list of the top 10, and it also happened to be the first one that I looked at, so I got really lucky in that I found a bug on the first. And actually, I did find a bug in another one, but it wasn't WCF. But I downloaded a bunch more antiviruses, and they weren't even using WCF at all. So anyway, the antivirus has a WCF endpoint which was intended to be used only by authorized processes. That it can launch a binary meant for updating the service. And the reason I know it was intended only for authorized processes is because when you try to talk to the service, it checks that the program connecting to the named pipe is signed by Checkpoint. So obviously they only wanted other Checkpoint programs talking to it. But the check was faulty. So yeah, so disclaimer, I'm not a good reverse engineer or programmer. I found the bug by reading the code and a lot of trial and error. And so anyway, after I installed the software, I ran .NET Service Hunter and I saw all these services. The next thing I did was to start opening them all in dnspy, which if anybody's unfamiliar, it's just a free .NET decompiler. And the nice thing about .NET is that it, in general, decompiles straight into source code with comments and variable names and everything. So it's really easy, even if you're not a good programmer like me. So the first thing to do if you're hunting for WCF bugs is to check for a reference to system.service model. This is a key dependency for WCF programs. So if you don't find a reference to that library anywhere, then the program is not using WCF. Now it may not be in the direct list of references, like it may be nested in one of these other ones, so you don't want to stop looking. Also, if you open Process Explorer, you can look at all the libraries loaded by the program, and that might be a faster way to see. But so yeah, so once I confirmed that it was using WCF, the next thing I did was just start looking for vulnerable functionality. I found a method called onCommandReceive, which at first I was hoping was just going to run a command, honestly. And then, but anyway, that command eventually triggers a call to another function called execute installer. And I like the sound of that, so. So here I'm showing the execute installer method. I'm not sure how well you guys can see this, but pretty much right at the bottom here, it's starting a process based on input that came in. It takes one argument, and so it can start whatever process gets passed in. So after finding a method that seemed potentially exploitable, the next thing that I wanted to do was figure out how to talk to the service. The service opens up two named pipe endpoints and has a custom add secure WCF behavior method called on them. This was a clue to me that the developers had done some work to try to lock down this communications channel. The other thing, instead of like in the example vulnerable service, I literally copy pasted the interface and pretty much built the client from scratch. In this case, there was already client code living inside of the installation path of ZoneAlarm, and it's a lot easier if you can find, like a proxy library for talking to the service and just utilize that code, because otherwise you're going to have to figure out, how it all works, and not only that, but if they're doing special stuff to try to add security to it, it's just going to make it that much harder to build a client. So anyway, inside one of the libraries, I found a method called setup WCF connection, which talks to a named pipe called Sequoia root. So I made a new project and imported. I added references to SBA stub DLL and all its dependencies, and just created a stub object and just looked in Visual Studio to see what kind of functionality could be called on that object. So One of the functions was called register stub, and I could see by looking at the log output produced by the antivirus before I even started messing with it that there were register SBA stub, lines in there. And so that was really helpful because I knew that if I successfully registered a stub, I still don't know what registering a stub means, but I knew that if I was successful, it would show up in the logs. So that was the first thing. I just wanted to get basic communications with this service working. None of my attempts to talk to the service were working. I wasn't getting my stub log. And it did kind of look like that, although I am standing here today too. So the problem is that when the name pipe server checks to see that the connecting client is signed by checkpoint. This check is faulty in a number of ways, and I posted this to Reddit last week, and James Forshaw replied back with like 2 other ways that I could have bypassed the check. And I also had another one that I hadn't even mentioned, but what it's doing here is getting the PID of whatever client is connected to the name pipe, bless you. And then by the PID, it gets the file name of the process. And when it reads this file name, it actually reads it out of the client process memory, which we have full control of. So I had kind of thought that might be possible, but I had no idea how to do it. And that was one of the things Forshaw pointed out to me, which was really cool. So, so I was happy and humbled to hear back about that. But that's not going to be how I do it in this exploit. So 2 options were considered to bypass that check. The first one was to inject the exploit code into a legitimately checkpoint signed binary. And the other option that I thought about but didn't try was to just sign the exploit with a self-signed certificate. I didn't know that non-admin users on Windows can trust root CA certificates, and so I could just trust my self-signed cert as a non-admin and then sign the exploit with it. So I didn't know that, so instead I used this GitHub project called Sharp Needle, which facilitates DLL injection of managed code, of C# code into 32-bit binaries. And they don't have to be .NET, they could or could not, it doesn't matter. And so there were a bunch of programs that come with the antivirus that I could launch as a user and then do DLL injection and just inject my exploit into it. And so that's what I did. And in this screenshot, the program that I chose to launch as a user was called zar.exe. It's signed, and I highlighted here and here just so you can see that the pop-up box got the icon of ZAR, so I knew I was running code inside of that process. So now that I had code running inside of a signed process, I tried registering a stub again, and it worked this time, so I got exploit stub. So very sick. So once I was able to register a stub, I started playing with the send command function, which takes one argument, a string called command XML, and it's literally just a string of XML. My assumption was that send command lined up with the on command receive function that I saw in the service. What on command receive does is it gets the command XML, it does some really minimal error checking, and then passes it on to another function called handle run installer package command. So handle run installer package command also just does some very minimal error checking and then passes it on again to a function called execute installer. And finally, inside execute installer, command XML is deserialized into a run installer package command object, which I'm showing here. And it's just an object that consists of 2 strings and a custom object that we don't even have to actually deal with called SBA message info. It doesn't matter for the purpose of exploiting the program. So in fact, the only one that matters is installer package path. That's the only field inside the object that we need to load. So yeah, so if the deserialization inside that method is successful, then the execute installer will check to see that whatever program is pointed to in installer package path is signed. Oh, that's up here. Yeah, so it checks to see if it's signed, and if it's signed, then it'll run it. So we just needed to load up our, create a run installer package command object, XML serialize it, and then pass it to send command. So that's what I did. But there was a problem because and I have a typo, there's a problem because the program that's going to get launched has to be signed too. So we already bypassed the first code signing check by doing DLL injection into a signed process. Once again, I was ignorant about the self-signed certificates, so my solution for this was to do DLL hijacking on again, a legitimately signed process. And so I took that same program, ZAR.exe, and opened up Process Monitor. So I launched it from just a random user writable directory, so it didn't have any of its libraries next to it. And I'm looking in Process Monitor to see if it, what DLLs it's looking for. And so there were a whole bunch. And what I did was generate a payload to launch calc with MSF Venom. And I placed that DLL and ZAR.exe in a user writable folder. I named the DLL version DLL because that was one of the ones that I was trying to load. And so you can see here that it worked. The service process started ZAR.exe, which then started to calculators as system. And so that was pretty cool, except for the antivirus had a feature called application control that I disabled at the onset of my testing just to make things easier. And I actually disclosed it to Checkpoint without having remembered to turn it back on. So they emailed me back and they're like, hey, your POC only works when application control is disabled. I was like, oh shit. So I enabled the application control, and sure enough, not only does it block DLL injection into a lot of processes, but it also kept removing my Venom generated payload, which I'm glad it at least could do that. I tried a whole bunch of ways to successfully inject code into that ZAR.exe with the application control, and I couldn't. And I'm not really good at that kind of stuff either, but I started figuring out like which API calls it had hooked and which ones it was blocking, and I tried all different ways to get around it, and all those calls were blocked too, so I was like, this guy. So self-signed certificates came to the rescue. I knew about, oh man, I'm going super fast. Holy crap. I had read this article before by Matt Graber, which explained how non-admin users could trust root CAs, but I didn't really have a use for it, but I remembered it when this came up, and so I asked my friend Ben to help me get that working. And so Windows 10 comes with a bunch of, it's not available before Windows 10 unfortunately, but Windows 10 and up comes with a bunch of PowerShell commandlets that make it really easy to do code signing with self-signed certs. And so this is the code. I'm not going to run through it in this slide because instead I'll run through it in the actual demo. So, sorry, this went way faster than I thought it was going to. So first thing I'm going to do is create a new cert object in PowerShell, and I'm just setting the. Oh crap! What happened? Oh, it's not on that screen. Yeah, I'll do that. And I'm going to reboot this piece too.
Use Windows because you prefer it, or it's a learning tool for you?
Sorry?
You like Windows, or is it just a way to learn how to hack better?
I like Windows and Linux. Always have Linux VMs open, except for right now because I'm doing a presentation. But yeah, I mean, I've been using Windows since I was very young. Okay, so creating a new cert object where the only field I need to manipulate is the CN due to the way that the service does the check. It only checks, basically it checks A, is it a valid cert? B, is the CN checkpoint software technologies. So both those criteria will be met. After I create the cert object, then I export it to the file system just so I can then import it. And this is the part that is like, why can non-admins do this on Windows? People can't, nobody has the answer. So after that, then I sign the exploit, which is going to be the client that actually talks to the service, as well as the payload, which is just an arbitrary exe to, in this case, it's just going to add a new local admin to the system. So I sign both those and then just run the exploit. Actually, before I do that, so who am I test net local group administrators. So I'm not in the administrators group, but after I run the exploit, there will be a new local administrator. Or not.
Run the previous commands.
Let me just run this all at once like I usually do. There we go. ZoneAlarm exploit user just got added to administrators group. So, yeah, so conclusion, we're looking for logic bugs pretty much. We're not doing any memory corruption or anything like that. It seems like developers are not, based on the other bugs that I've looked at, they're not really being conscious of the fact that people are going to figure out how to talk to these services other than the, who they intend to. And so they're leaving all this sensitive functionality exposed. In other cases, like in this case, attempts have been made to prevent unauthorized processes from communicating, but the means by which they do that are faulty and can be bypassed. How to fix, don't expose functionality that can be abused. That's what Checkpoint did after I sent this to them. Yes, sir.
So they drop functionality instead of just like actually fixing the issue with certificate pinning? They
did, yeah. Which also, Forshaw said was a good idea because there was other ways around it. Like I said, by manipulating the client process memory. And also, there's also a way to do it without having to export a cert and trust it on Windows by copying the signing structure out of an existing signed program. And that's due to the way that some of the calls in C# work, which I couldn't explain to you. I still haven't.
I know there's like this way you can like spoof, like it's already a signed thing, but they still trust it even though you added like a bunch of junk to the end or maybe the start of the executable. Forget like.
I need to dig into his response to understand that part. There was another bypass too, which was that it gets the client file name by the PID. So he was saying you could connect as a signed process and then suspend one of the processes and then start a bunch until you get the same PID, which I don't exactly know exactly how that would work. He didn't make it sound like it would be easy. The one about modifying the process name in memory was the most interesting to me. But yeah, Checkpoint, they just killed the on command receive function basically. And I guess their software can still do what it needs to do, but instead of having a function where you can pass a path to it, they just have hard-coded strings now. And I guess the only reason there's multiple paths is for if the system architecture changes, although it was always 32-bit when I downloaded it. So anyway, they figured out a way to do what they needed to do and still be able to kill that function. And so that was their fix. But yeah, pretty much you need to be conscious of what kind of functionality is getting exposed. And then other than fixing, honestly, I'm not that interested because I like hacking stuff anyways. That's it. I can take questions or just be done.
Any questions for Chris?
Yes, sir.
Back.
Just one. I remember you said you were looking to start with the source code.
Yes.
So my question would be, how far do you think you would have gotten if you had not had the source code?
I would have never got it.
I mean, you never thought of what it might take to decompile and so forth?
Well, that's how I got the source, was by decompiling the code.
Okay.
Yeah. No, they didn't hand me the source or anything.
Well, that's what it sounded like. You should start with the source. So.
I mentioned DNSpy in the beginning, which is, again, it's a free .NET decompiler. Sure thing. Anybody else?
It sounds more impressive when you start with the object code. It is more impressive.
All right, cool. Thanks. That's all I've got tonight. I want to thank all of our presenters. They were great. It's a very wide distribution of kind of ideas. Let's also thank Insight Engines for hosting tonight. Let's get these guys up on the way out. They want to hear more questions. They want to hear hopefully more ideas that we want to have AI do for you. Thanks everybody.